Hello, everyone. Welcome to Jump On Air. We're so happy you've chosen to spend some of your day with us as we explore data, statistics, science, and of course, Jump. My name is Julian Paris. I am the Learning Strategy Manager for Jump Software, and I get to be your host for Jump On Air. We've got a really great show for you, full of inspiring speakers who have stories to tell and knowledge to share. I'll show this schedule throughout the show, and I want you to know why. I'm going to keep us on track to the minute as best I can, because I know that your day is packed and you have other responsibilities. So I want you to know that if you have to leave, you can always come back and join for the shows you want to see. And in fact, we tried to make that really easy. You can always go to jump.com/jumponair, and that'll reconnect you to this live stream. Have to go up to the kitchen to grab some food? Put us on your iPad. Are you going for a run in the afternoon? Go ahead and take us with you. Jump.com/jumponair will connect you back to this live stream so you can view any of the programs you want, even if you've disconnected. So please do that for us. After the show, we're going to redirect you to community.jump.com. There's actually a page we built out for this very episode, and we'll do this for every episode going forward. So that'll include all the links that any of our panelists and speakers show. It'll include any of the data sets that we show and include in any of our broadcasts. And it'll give you the opportunity to comment on your favorite shows and tell us what you want to see more of. The whole point of Jump On Air is for us to connect to you, our Jump users. And so we definitely want to hear from you what you want to hear more of. Because this broadcast, really, it's about you. The whole purpose for putting this together is so that we can connect with you and you can connect with us. And the best way to connect with us, as always, is community.jump.com. So look for that. You'll be redirected right after the broadcast, but you can always find us at that URL. All right, so to kick things off, and before we get to our first speakers, I actually want to take a moment to do a little segment that I'm calling Today I Learned. Now, you probably already know that this is a hashtag that people use. They say TIL. In fact, if you didn't know that's what TIL stood for, now that's the thing you learned today. So you can tweet out TIL, TIL. But I want to amend this a little bit. I want to actually do something called a till surge. Today I learned something really good. So hashtag till surge if you want to do that. In fact, if you want to tag me or mention me in your till surge of the day, go ahead and do that. But in all seriousness, I wanted to do this segment because, like you, I probably seen a lot of rather negative things, and the news has been a little scary out there. We can't avoid that fact. But that doesn't mean that there's not some really, really amazing and great things out there. And so I wanted to spotlight some of those amazing and great things that I came across, and I want to do it in just about 5 minutes. So to do that, I actually have to tell you about a couple different things. And the first is I need to tell you about a supercomputer. This is the current fastest supercomputer in the world. It's called Summit. And Summit is at the Oak Ridge National Laboratories. It is an impressive computer that puts out at max about 200 petaflops. Now, if you don't know what a petaflop is, that is, let's see what it is, 1,000 million, or 10 to the 15th power flops. But if you don't know what a flop is, that's maybe not that helpful. A flop is a floating point operation per second. It's kind of like the basic unit of computing speed we use for measuring supercomputers. It's essentially how fast a computer can do one particular mathematical calculation. So it's a pretty good unit. And Summit can do 200,000 million floating point operations in a second. So it is a beast of a computer. Okay, so hang on to that. The next little bit of things I need to tell you about before I get to the good thing I came across is I need to take us back in time about 16 years to the computer I had in 2004, decidedly not a supercomputer. So that's actually the setup I had. I have my 2 CRTs, and I have my first flat screen in there. And so that computer, that was a Pentium 4, 2.8 gigahertz Prescott processor. And you might think it's weird I know exactly that, but I actually keep all the processors from my old computers. And so this is the brain, really, from that computer. I named it Halcyon. So this is Halcyon's brain. But this processor, if I'm being really generous, pushed out maybe 4 gigaflops at the very most when I had it overclocked and overheating itself. So not very fast in supercomputer terms. That's 50 million times slower than Summit. But you might think that's not totally fair. Summit is a modern supercomputer. So compared to the supercomputer in 2004, the best one, which you may have heard of, this was Blue Gene, putting out 70 teraflops, an order of magnitude slower. My little computer there, Halcyon, was about 18,000 times slower. So slow by comparison, but if you think about it, that's not that bad still. It only took 18,000 of my computer to reach a supercomputer level. All right, so the third piece of information I need to share with you is that I've always loved science, and I have the credentials to prove it. This is actually my certificate of recognition from third grade that I was the best scientist in third grade. So thank you, Wallace Watson. So I think my credentials here are unimpeachable. And in 2004, I came across an organization called Folding at Home. And Folding at Home had the same idea that I did, not surprisingly, that we can take thousands and thousands of personal computers, pool them together, and do amazing things. And Folding at Home had a project, which was to bring together these computers to do molecular dynamic simulation, which is an incredibly complicated computational problem. But they can do that to solve things like Alzheimer's, Huntington's, do cancer research and viral research. So Folding at Home was this great organization you can contribute your computer's time to, and I did that for a while, probably up until 2006, when they actually broke the petaflop scale. So they had a network of thousands and thousands and thousands of computers, just like my computer, that were contributing their time, and they were able to turn it into essentially a supercomputer. All right, so I sort of forgot about Folding at Home for a while, like I think a lot of people did. I upgraded away from that computer, and I didn't reinstall the software. So about a month ago, I came across this news article, which was that Folding at Home, based on sort of everybody now rallying together because of coronavirus, had contributed so many computers and Xboxes and Bitcoin mining arrays that they were now faster and more powerful than the top 7 supercomputers in the world. That is, they had reached 470 petaflops, more than double Summit. And that's an incredible thing. If you look at the actual title of this, it's that our fight against coronavirus goes nuclear. And in a way that's maybe even almost accurate. I just want to give you a sense of the scale of this. If we look at this in Graph Builder, so I actually just have a data table here of the top 500 supercomputers, and I'll be sure to share this. But if we look at, this is Summit right here at the top. This is Sierra, the next biggest supercomputer. But if we look at what happens when I put Folding at Home from last month on there, it is just so much more powerful. Double Summit, and if you add up the top 7, it is more powerful than that. And so that's a pretty darn impressive thing that people coming together has accomplished. And that news story got some traction. But that wasn't the thing I learned that was so good. The thing I learned that was so good was only about a week ago, because of everybody contributing their time, Folding at Home broke the exaflop scale. That is, more than 1 million people are contributing their computers, their Xboxes, their PlayStations, their Bitcoin miners, their Android cell phones. They're contributing the spare time and processing time of those machines, and they've now pushed our computing power as a civilization faster than it's ever been, faster than all the supercomputers every government had ever put together. We have put together that computer. And if we look at it on the same scale, let me take away February and put on March Folding at Home. It is an incredible beast of a computational power. And they are throwing that entire network at these molecular simulations to help solve the current crisis we're in. And so if that's not something really good, I'm not sure what it is. It's a great sort of message that speaks to how we can all come together and do amazing things. And, I think we've all seen the trivial examples of us getting on each other's nerves, whether it's fighting over toilet paper at the store or people getting angry when you ask them to back away from you at the supermarket or with their carts, right? Those are small examples, but this is a huge example of the exact opposite, where I think we know we can come together and do amazing things. So, Till Surge, that was the thing I learned today that was really good. Please contribute your time, like me, to foldingathome.org. You could download the app on pretty much any device and contribute a little bit of your computer's spare time and spare computational power. And so together we can do something pretty amazing. So that's Till Surge. Now, I want to turn it over to our actual programming. Our first speaker, our first presenter is Russ Wolfinger. He's going to be speaking with Ann Milley, and he's going to tell us about some of the lessons he's learned by working in data competitions. And I'm really excited for this talk because Russ is an incredible person with an incredible story, and I can't wait to hear a little bit more from him about what he's been working on as well.
That was a great intro, Julian, and all that doing good for others is relevant to what Russ is going to talk about today. Always excited to feature Russ. He leads the Life Sciences R&D group at JMP and has won many awards and accolades. and he's a member of the American Association for the Advancement of Science, as well as the American Statistical Association. And I could go on, but I want to keep this short so that you can hear from Russ. So welcome, Russ.
Hi, Ann. Thanks a lot. Great to talk with you. And hello to everybody joining in today.
And for those of our viewers who don't know you, please tell us about your role at JMP.
Well, I've actually been at SAS my entire career, 30 years now. And about half that time I spent in the SAS R&D statistical group developing SAS statistical procedures, and then in JMP for the last 15 years or so. And our team, our life sciences team, we're primarily responsible for 2 vertical products that work with JMP Genomics and JMP Clinical. And we've got a great team. We have a lot of fun, and JMP is just an amazing platform to leverage into those 2 domains.
Agree. We know that you're a super curious lifelong learner, and I'm just curious, what attracted you to statistics versus some other field?
Well, I guess I was always kind of a math nerd, and I met my wife Liz in undergraduate, and we got married soon after college, and we both loved school, and we decided to go to grad school together. And by the way, shout out to Liz for setting me up in this nice little Zoom area today. I usually am holed up in the basement somewhere, which had a horrible looking background. So she's like, you got to get up there. But we ended up both going to NC State, and I ended up getting a nice deal there with the statistics department. And Dr. Tomvik was really friendly and me. And so in one sense, it was kind of serendipitous, but on the other hand, we're just in this age now that is, as you know, flooded with data from just about any discipline. And so statistics is a pretty natural thing to look into. You're going to run across it at some point if you do anything with data.
Right. Well, as someone who has developed widely used statistical algorithms for users who have to know how to code to use those algorithms, what attracted you to JMP, where many of our users don't code?
Oh, you know, for me, I guess one of my life's passions is to write software to help people analyze data, I guess in a broad term. And so the SAS stat field, it's been very popular, a lot of users. But thinking more broadly with JMP, I think a lot of it has to do with this little guy right here, the mouse. There's so many more people who I think are interested in data these days. They may know some coding, but they don't want to sit down and write code every time you get some new data. And that's where JMP is just so amazingly powerful. I've used it, and just with the mouse, you can do some pretty amazing things.
Very cool. Well, you have one of the best medal-winning records at Kaggle, or on Kaggle, I guess I should say. Some of our viewers might not know what Kaggle is, so could you explain that?
Oh, sure. Yeah, in fact, I didn't know much about it until maybe 4 or 5 years ago. We had just wrapped up a new predictive modeling framework within JMP Genomics, and had participated in another a data science competition site called Dream, and done pretty well. But then we found out about Kaggle. It's actually kind of it's really exploded over the last 5 years or so. I think it got its start as kind of a data science competition framework, where sponsors will present a problem to the community. Typically, it's a predictive modeling type problem where they'll hold back some of the data and give the rest out for training. And then the competition is to predict what they held back. But since then, Kaggle's kind of really grown into, they've got data sets now, just of them. They've got a learning framework. And so they self-describe as kind of the home of data science. And I think they kind of have a claim, a legitimate claim for that.
So it's almost like a platform for collaboration where people can come together and do great things by collaborating.
Yes, and one of the really valuable things is it's a gold mine for some of the most cutting edge data science techniques. Most of the time, after a competition concludes, the winners will graciously share what they did. Mm-hmm. Often they'll even share their code, or at least the techniques that they followed. And it's just amazing, especially if you've been working on the problem yourself, to see what others did and other sharp data scientists from around the world. And it's got a completely international participation from just every major country all around the world. And Kaggle also offers free computing power. So if you just have a web connection, you can get on there and do not only learn, but also compete if you want to.
So you've already talked a little bit about what must attract you to some of these competitions, but what are some of the other things that attract you to compete on Kaggle?
Oh, well, I guess I've kind of been a competitive person my whole life. I've done a lot of different sports, not always that great at it, but get out there and try to do my best with whatever I'm doing. And so it was a pretty natural fit. This is a chance it appeals a little bit more to males. I don't know about that. We just tend to like to see our name up on the leaderboard. Maybe it's kind of a cheap incentive, but for some reason it just meshes pretty well with what I like. And I think overall, though, the real value is the ability to collaborate with some really top-notch folks on certain problems. And I've made some really good friends just over the last couple of years looking at different competitions.
Very cool. Well, I believe it was your participation in the Rossmann competition, forecasting competition, where you learned that XGBoost was surprisingly good with time series data. Can you please elaborate?
Oh, yeah, in fact, I pretty much credit this. What kind of got me sucked into Kaggle. I had really long classical time series training at NC State, and set course the SAS ETS framework is very well known for all the latest methods. And I think my very first competition, it was also time series based. I was like, I'm just going to go in there and show these guys what the real stuff looks like. And I just got hammered. I mean, I did horribly. I tried everything I could think of, everything I learned in school, and the best I could manage. I think maybe I got in the top 25%, or I don't even think that, maybe the top half. And then right after the competition, like I mentioned, the winners posted what they did, and all of them, it turned out, had used this package called XGBoost. And I was like, what in the world? I'd heard of basic decision trees, but this is kind of a more modern, boosted version. A lot of the theory had been developed in the statistics community, but then picked up by data scientists. And then XGBoost framework itself was developed at the University of Washington and put out there in open source with interfaces primarily in Python or R. And man, it's pretty amazing. And in fact, in a little bit, I'll show you some things that we've got going with it.
Good. Yes, looking forward to that. But first, just a little bit on to what do you attribute your Zensemble team's success on the Zillow competition? And I love that name, Zensemble. That's very clever.
I usually try to come up with some clever names. Sometimes they end up being kind of silly. Yeah, well, we did use boosted trees for that. And that was a really intense competition, a huge data set involving just millions of homes. We were trying to predict what they were going to sell for in the future. And I had two really great teammates, Dimitro from Australia and Jonathan from Israel. We were literally maybe about as far apart as you can imagine on the globe, the three of us, but through Slack, we were able to communicate very effectively. And we engineered a lot of features and tried all kinds of different things, and were able to use boosted trees to pretty accurately predict what those homes were going to sell for.
So cool. Well, how do you think that winning model would change in today's economic reality?
Yeah, well, certainly nowadays with coronavirus and all kinds of crazy things happening. Of course, any kind of predictive method is subject to flaws and things that can trip it up. What I like about the boosted trees is they do seem able to pick up kind of anomalies rather quickly. Their underlying computing kernel is a tree, which by its nature will split the data and look for jumps. And so I think if anything, maybe the modeling approach wouldn't change that much, but the actual forecast would, and there would be new features, for instance, around the economic impact of the virus that would likely be good predictors at this point.
Interesting. They may want to revisit it on Kaggle.
Yeah, I'm sure Zillow's scrambling right now in other places. There's all kinds of markets. Just about every market, I think, is being impacted somehow.
Right. Well, please tell us about this latest Kaggle competition you're working on, and show us a little bit of what you've learned.
Yeah, in fact, kudos to Anthony at Kaggle that they put together kind of a rapid response series of competitions week to week on analyzing the coronavirus trends worldwide. And JMP was one of my Kaggle secret weapons. I think every new competition that I choose to do, the first thing I'll do is open the data up in JMP and just play and explore and see what we've got. Can you see my
Yes.
screen okay, Ann?
Yes.
You can see it? Okay.
Mm-hmm.
Great. And so what you should see now is a JMP table. And I just downloaded this. This is brand new, downloaded from data all the way up through yesterday. What we were tracking here are two main features related to the virus: the number of confirmed cases and the number of fatalities. And I've actually this is not exactly the raw data. I did a little to save time. I've done a little bit of feature engineering up front. But the main data that we have here, let's take a look. We can just do a quick, often what I'll do is just a quick distribution analysis in JMP. And we've got countries and regions, provinces within those. And so one thing I did quickly was to build a single variable indicating location. The data run from January up until just yesterday. And by the way, JMP is interactive, so it's often nice just to see, you can click on different places and see connections. And then you can see here that the two things we're trying to predict are the number of confirmed cases and number of fatalities. And Kaggle recommends that we switch to the log scale. So these two variables, y0 and y1, are the log x+1 transform of these two. And so that's what we'll be looking at and trying to predict. And the first thing, I think a natural thing to do is to go ahead and just plot the data. And so here we are now in Graph Builder, kind of a messy plot. Sometimes people even call this like a spaghetti plot. But these are the time trends for every country that we have. And I think we're now there's around 300 different unique regions that we're plotting here. The one that leaps out immediately is here, the Hubei province in China, where it all got started. And you can see the curve wasn't exactly smooth. For example, this was, I think, the day that they changed their definition slightly of what a confirmed case means. And then here's where I've also got a nice local data filter that can be handy when you've got a lot of messy data like this. Let's go ahead and just zoom in on China here for a moment. These are some of the other provinces, and you can see a lot of them have just completely flattened out. Except for a couple, and I was curious about these. There's Hong Kong and Macau. So those, as you know, those are the two cities way down the southern part of China. A little bit different dynamics there. But let's go ahead also then and take a look. I guess of interest for a lot of our viewers are here in the United States. Let's see what the US data looks like. I'm scrambling here, trying to keep the screen large. Okay, here's the United States data. The immediate thing you see is it looks like we've got nothing before March 10th. And it turns out these data were collected from the Johns Hopkins site, and they've been curated a little bit further from there. But that's a great resource, I think, and kudos to Hopkins for assembling. They do a lot of curation themselves, and then Kaggle does a little bit more. But my understanding is the US data was collected at more of a county level up until the 10th, and then they were able to aggregate and get things going. So you can see here the top state is New York in terms of number of cases currently. New Jersey is second, and then a whole big cluster of states here. Here's an unusual one at the bottom, the Virgin Islands. So it looks like they actually maybe even had some reporting issues here. So that data is probably not exactly right. These are cumulative, supposed to be cumulative counts. So the curve should be monotonic, non-decreasing. So anyway, that's a quick look at the data. And what we want to do here, just in a short time, is let's forecast our curves out for a week. And so what I've done, we've got data up through today, or up through yesterday, April 2nd. And so we'll forecast what's going to happen today, and then out through the 10th. And we're going to use XGBoost to do that. Now, ordinarily, I would I would do an XGBoost style analysis in Python, which is the most common interface, but we have just recently created a brand new add-in for JMP itself, with which you can actually call XGBoost right from JMP and do prediction right with your mouse. So we're pretty excited about that because it opens up the power of XGBoost to a whole broader range of users, and many of those listening wouldn't be necessarily interested in sitting down and trying to crank out XGBoost predictions in Python or R, but they would be very glad to use their mouse and just with a couple of clicks be able to create these nice boosted tree predictions. I did want to mention in JMP, there are also other nice places you could look at. For example, Functional Data Explorer is really nice for looking at time series, and I'd encourage folks to take a look at that. And of course, we have several of the classic time series methods as well, which are relevant. But this XGBoost is kind of a unique new way to do it. And like I said, I've had a lot of success with it on Kaggle, and so it's my natural go-to for a new problem like this. The one catch is you do need to create some features. It's not just completely automatic. And what I've done here is I've got just a handful of features that I would consider critical. The first would be naturally the location. And as we saw in the curves there, several of them have different shapes. So it makes sense to let XGBoost know about the location of each curve. And then I created sevens if we're going to forecast ahead for 1 week. And then finally, these last two columns I labeled a reference day. These are the first day, these are the days of the first occurrence. So for example, here we're in Afghanistan currently, and this you can see the first fatality in Afghanistan happened on March 22nd, which is the 82nd day of the year. And that value of 82 is now propagated as just a single feature. So this effectively allows us to align the series. And it turns out we do this kind of thing commonly in JMP Clinical. We call it patient starting day, where in a clinical trial, patients will begin at staggered times, but we often will like to line them up on the first day that they begin. So same kind of idea here. And now to do the forecasting, I've got my own little custom bar here. You would typically, if you're going to use it, you'd want to use this add-ins menu. And go to XGBoost. And this is it's an add-in that again, you install it with JMP Pro, and then you can call it directly just like any other JMP platform. Now what we'll do here, we've got the two variables we want to forecast. And again, these are on the log scale. And then what you do is load in the things, your features. We're going to use location. It's nominal. And then we've got four continuous features here, the two lags of our two variables and the two different reference days. And then to get started, usually you want to set up some kind of validation framework instead of just quickly or blindly forecasting in the future. The game you want to play is, if we pretend like it was 1 week ago and we want to do the same thing, let's forecast ahead a week. And then what we can do is use this as a validation holdout set, fit the model from using only data from a week ago and before, and then see how we did. And that's a great way usually to check and test your predictive models to make sure they're working well. So now that we've got things set up, you can hit OK. And you get the second dialog to help you idle bits of XGBoost. It turns out, I mean, XGBoost is really kind of it's very tricked out boosting framework. It's got all these parameters that can be quite overwhelming when you first see them. And we did some work here to try to separate the advanced ones from the more common ones. And the most popular ones that I tend to use the most are here listed. And we also have a facility for tuning these, which for sake of time, we won't be able to do. We'll just go with the defaults for right now. And so I just click the go button, and this is just running on a PC at work. And we fit both responses there. You can see just in a couple seconds that these data are not that large, although XGBoost is pretty well suited for larger data sets. And we've got training and validation curves here. Our goal in this case is to minimize root mean squared error. And as you can see, the platform kicks out several useful diagnostic plots. You can tweak what metrics you're looking at. These two plots are plotting actual versus predicted for the training, and then for the validation sets. The validation is typically the most important because that's measuring truly how well the models did predicting into the future. This is for Y0, and then you can scroll down and also look at Y1. These are the log fatalities. And you can see overall you want things to cluster around that 45-degree line. And for training, certainly they do perfect predictions, but not too bad. Yes, you'd want to compare this to some other benchmarks just to see, but I think these actually are pretty reasonable, at least as a first go, just with these few features that we have. The other nice thing about XGBoost is you can immediately get variable importances. And here we can see these are the variables that throughout the course of the boosting history were chosen the most frequently and produced the most gain with the model. And you can see our lag feature here came out as number 1. There are 2 reference days. And then the model started partitioning out different series. There's Hubei, which that's maybe not so surprising. And here's Diamond Princess. That was the, if you remember, that was the cruise ship that got quarantined and set off the coast of Japan, and then a few other countries. So that can really be interesting in terms of interpreting results and seeing kind of opening. It's not just a black box framework. You can actually see how it's working. But then just to wrap up here, since we don't have a lot of time, main thing we want to do is predict. So what we'll do is we'll save our predicted values. And what that does is create new columns back here in the table, including, most importantly, the forecasted ones. And what we can do then is go back to our graph builder. And we'll have to go back to our control panel here. And we can see now we've got our predictions. And we'll add that to our graph. Really getting messy now. But let's go ahead and do our zoom ins. You can see now what we've got. We've got the original data, or the dark curve, or the solid curves, and then our forecasts going out into the future. And let's just go back to the US here. So you can see this top one here for New York. The forecast isn't I wouldn't consider that really great. In fact, it's already kind of under predicting. The strength would be mostly in the middle here, and you can see most of the curves are coming up. They're not all just kind of simple mathematical models, but XGBoost is really trying to mimic the data. And in fact, for the Virgin Islands, I found this kind of amusing. You can see it tracking the poor data pattern, which is wrong.
Oh, yeah.
But at least in a way, it's kind of informative because it shows you how these it's definitely pulling off of the lag feature, right, and somehow going down. So this would be a case where you want to go in and clean out the data. Right. But anyway, I'll save and upload this. We'll upload this table to the community if you want to play around with these forecasts and maybe try some of your own.
Awesome, Russ. Thank you so much for sharing that. And I know you've commented previously that this algorithm is really good with messy data, for sure. Thank you so much, Russ. Really appreciate you taking the time. Very interesting.
Welcome.
And good luck in your competitions.
Thanks a lot.
Thank you.
Thank you so much, Russ and Ann. That was a really informative segment, and I'm so happy you were able to join us, Russ, to talk with us today. I'm sure we have a lot of comments from people who want to see more about XGBoost, so maybe we'll have to have you on in a later episode to do a deep dive for us on how you set all those advanced tuning parameters and help us, if we want, win some Kaggle competitions. So our next show is going to be Tip of the Day, where Pete and Mary are actually going to take on some roles and tell us about a tip and jump that we can apply for ourselves right away. So Pete and Mary, take it away.
Hi, welcome to the tip of the day from JMP On Air. Today, Mary and I are going to be going through a setting preference preferences. The idea is Mary is a new hire, and she is trying to get her Jump to reproduce these reports the way that our management wants to see them. So, Mary, you want to take it away and share your screen?
Oh, thanks, Pete. So, Pete, you sent me this journal with the way that our management likes to see the distribution reports. But when I run the distribution, my output looks like this. And I don't know how, besides going under the red triangle every time I launch a distribution to set the settings to look like yours. Is there a way to do it more permanently so when I launch the distribution platform, it will come up and look like what you sent me in the journal?
Yeah, great question. And this is a big time saver. So to be able to do this and reproduce this, the best way to do that is to set it in your preferences. And you find that under the File menu.
Ah, the File menu.
Yeah, and then
there it is, Preferences.
Yeah. So let's set the distribution preferences, and we find that under Platforms.
Platforms.
Yep. And then if we scan down to Distribution.
Distribution.
So if you remember, our boss, Bob, doesn't really like seeing those quantiles. So if we turn those off.
Okay.
And then he likes to see it in that horizontal layout. So let's change that to stack. And then one other thing that he really likes is to have the order there of the categorical variable. So if we scan all the way over, by default, it's ordered by alphabetical order, but he likes to see the largest to smallest. So if you turn on that order by and click that on, and then change that to count descending, and then we hit OK. Okay, so now if you rerun that distribution.
Recall, one of my favorite.
It's super handy. Now you can see.
Look, yeah.
exactly
like
how Bob likes
Pete.
to see it. Yeah.
Wow. So you go File Preferences allows you to set a more permanent display for your platforms.
Yeah, absolutely. Did you have any other questions or?
I do. Last week when you were presenting in Jump, when you had your pointer, you were able to move it around, and there was a orange line that you had. How do I set up a pointer like you had?
Great question. That is under Preferences as well. Do you remember where we found that?
File, Preferences.
Yes. Yep. Now, instead of Platforms, we find this one under Reports. So if you go over to the left and the second from the top.
Oh.
And you see about halfway down there something called Laser Pointer.
Yep.
And by default, that's off. And you can turn on and pick from a variety of colors. I prefer orange, being a Bronco fan, but you can pick something else if you'd like.
I like blue, being a Giants fan.
Hey, that's also a Bronco color. I'll take it. Now, when you hit OK and turn that on, anywhere in a blank spot in a report.
Oh, awesome.
Yes.
Now I can be like you, Pete.
Exactly like me.
Well, thanks for the tip today to set this up, because I was going crazy every time I reran the distribution to have to go under the red triangle to reset these things up. So this is a more permanent way for me to have the display the way Bob likes it, our manager, and be consistent with the reports being generated for the company. So until next time, to my next question, I hope you don't get tired of me, Pete.
Yep. Thanks, Mary. And that was our Jump On Air tip of the day.
Fantastic. Thanks so much, Pete and Mary. If any of you have tips out there you'd like to share with Pete and Mary, you can actually leave them a comment on their community page for their Tip of the Day episode. So submit your best tips or ask them tips that you'd like them to share, and we'll have them back on the show to share more with us. All right, next up, we're going to actually ask the data doctor to take us through some tricky things to do in JMP normally and show us some easy ways to work with very difficult things with date and times. So, data doctor, take it away.
Hi, everybody. Thanks for joining us. And today we are going to talk about date and time issues. So welcome to the Data Doctor. And what this show is going to do is just discuss different ways to massage your data, maybe convert different formats, reshape tables, what have you. There's lots of different ways for JMP to do that. So we'll go over some that may be new to you. It may give you some new ways to think about things. So let's start today with a scenario where, you know, I've got a data table here with some dates, and I also have some data to go along with that, and I've got a nice graph that comes up. Okay, and this is, maybe I like this graph a lot, and I think, wow, I'd love to do that with my own data. And so that's easy enough to do because I can just come here and copy this script and then run it on my own data table. So let's say I go and do that. I've got this other data table. Looks pretty similar. It actually looks almost identical. And I go ahead and run this and I get nothing. So the question then is, what happened and how can I fix this? And so, you know, we try to do some investigation. There's nothing that really looks different here. These data tables have the same number of rows. They've got the same data types, it looks like. You know, we got a categorical date and continuous apples for both data sets. So this, you know, we're kind of wondering what's going on here. We could take a look at the distributions of those values with these graph headers. This is new in JMP 15, so this is a really cool feature. And due to the way these data are distributed, there's actually nothing I can see here either. So now we're maybe a little bit worried, you know, what's happening here. And let's increase the width, okay, of both of these columns. Let's look at the first data table. Notice how both columns are right justified. What that means is that JMP is representing these values as numbers. If I look in the second data table, the date is left justified, okay? It's aligned to the left, and that is telling me that JMP is representing those as characters, and that's our problem. So this is a case, and this happens a lot to people, where JMP is representing the data as a character, just like a string, like Joe or Bob, okay? And so JMP cannot, you know, use that the way you'd like it to be used. So what we're going to talk about today are some ways to get around this, to get JMP to do what we want. And we'll go in increasing order of difficulty, if you will, or just, you know, I guess time investment. The quickest, easiest way to do this, if you can, is just change your data type and then change your format as you would like it to be. So we'll see if that works. If that doesn't work, then we'll go on to steps 2 and 3. So for this example, let's go back to that second data set. And to change our data type, we're just going to right click on the column header, go to column information, and we're just going to try to change this data type to numeric. That's what we want, and let's see if that works. And we can see that it does work. Okay, if I drag this further out, the column width, I can see that all those values are aligned to the right. They're being represented as numbers. And, you know, for those of you that are interested, this is actually, each of these numbers is the number of seconds since January 1st, 1904. And so you can see they're all pretty large numbers. Now, this probably isn't the way you want to look at the data, but the fact of it is JMP can still use this data intelligently. If I just run the script, I do get the graph I was after. And because I've used different formatting in the x-axis, I'm still getting my years to show up. That said, you probably don't even want to look at these this way in your data table. So once you've managed to convert these to numbers, it's easy enough to go back into that column information and just pick the format you want. So you've got date and time formats down here. And if you pick a time format, you'll get hours, minutes, seconds after the date. And if you just pick a date format, you will just get the date, month, and year. And I'm going to just pick this format. This is the format I like: day, and then a 3-digit or a 3-character month followed by years. And we'll go ahead and hit OK. And so now we can see that these formats are going to match. If I decrease the width of these columns and go back and compare to that first table, you know, as you can see here, everything looks the same. So that's your first thing you're going to try. First thing you're going to try is to change the data type and the format to be what you want. Well, what if that doesn't work? Let's show an example where that doesn't work. Here, I have lots and lots of different formats. Okay, and if I just try to change any of these, let's just right click here and try what we did before. I'm just going to change this data type to numeric. Okay, and I hope it works, and oh boy, I lost all my data, missing data for everything. So that clearly didn't work. I'm going to undo that operation. And so now I've got to try something else. Well, let's try the InFormat function. And so we're going to build a formula column, and we'll use a single function and see what happens. And so notice in this data table, I have lots and lots of different formats. If I look at this example column, this data is all character data, and it's all represented with the exception of these last 4 lines, which are in the same format. I've got different formats for all of these lines. So there's a lot going on here. Let's see how many of these JMP can handle natively. I'll double click to make a new column. I'll right click and select formula. And then if you go ahead over here to the date time section, you'll see a little bit of the way down InFormat. So that means input format. So we're just going to, in this first argument for string, we're going to put the column of interest, and I'm not even going to bother with that second column right now. I just want to see if I can turn this thing into numbers. And look, okay, this works a lot of the time. I mean, actually, there's only, let's look at the missings here. Okay, 14 out of 55 cases are still missing, but the rest of them JMP digested. So all of these different, if I invert this here and take a look at these formats, all these highlighted formats, JMP can deal with them natively. You don't have to do anything. You just use that InFormat function, and you can turn these into numbers. And once you've done that, then you can set the format like you did before. So I can come over here and just say, let's put a time on these, and this is the format I like the best. Date, month, year, hours, minutes, seconds. Hit OK, and we've turned all these into times. So that's going to cover, 90% plus of your cases, unless you have a really strange format. That'll do. You're probably only going to get to the first 2 steps in these fixes. For everything else, we've got, or close to everything else, we've got an add-in that you can use to customize how you look at a character string and turn it into a date. So let's take a look at that, where you can find that. If you go to the JMP user community, you scroll down into this first row here, you'll see the file exchange. And so if I click there, that's going to take me to another page where I can select add-ins, scripts, or sample data. And you're going to want to pick add-ins here. And when you get to that page, you're going to type data table tools. And so the first hit that comes up is the data table tools add-in, and that's what we want. And so when you click on that link, it'll take you to a place where you can download the add-in. So you'll just click here to download the add-in. And once you've done that, if you go back into JMP and open that add-in, you'll notice that it is now living in an add-ins menu. And so mine is right here, data table tools, and I've got all my choices here. So we'll talk about that in just a second. So let's suppose you've done that and you would like to, I'm going to delete column 3 here just to clean things up. Let's suppose that I want to convert this date, this character string into a date. All right, how can I do that with the add-in? Well, let's go to the add-in. And you could just come here to special formula columns and open up the custom date formula writer. In fact, I'm not going to do that. I'm going to run all of these in a separate table. This data table tools has lots of different applications in it, one of which is the custom date formula writer. And I'll just leave this open so I can click that link anytime I like. So let's go ahead and click that link. And we have to pick a data table. And the data table we're working with right now is this example date formats. We pick a column where our date of interest lives, and the first row in the table is returned, only the first row. So for the table we're using, you know, I'll end up writing a formula that can convert this first row, but these other rows are not going to be converted. So this add-in assumes, as is the case usually, that I've got a data table and all the dates are in the same format. It just may not be the format I want. Now there's two ways to delimit here. Okay, we'll do an example of each. The first way is when you've got character delimiting, like something is setting off fields, whether it's commas, colons, spaces, what have you. And that's what we have here. When you click on a delimiter, it will highlight that and highlights all the rest of those spaces so that you don't have to do it over and over. So we've got spaces now. I'm going to click on commas. We've got colons. And once I've done that, everything's broken apart. These are the chunks that I need to process. We look at our year. It's a 4-digit year. So we make sure we've made that selection in this little radio button, and we'll just apply the delimiting. And we just go through and tell JMP what each of these fields mean. So March is our month, and we have to pick what kind of a month it is. It's a complete name month, as opposed to a numeric or a 3-letter month. 22 is the day, 1999 is our year, and then we've got 5 hours, 6 minutes, 7 seconds, and here we've got an AM/PM designator. And once we've filled this out, all we have to do is determine if we'd like an hour offset to be used. And you know, you can see here that our time zone is Central European time. So if I want to leave it in that time, I don't apply an hour offset. Maybe I'd like to convert that to Greenwich Mean Time. Well, then I could apply the hour offset that is applicable here. And then I pick the display format I want. We got lots of choices here. I'll pick my favorite. That's it. Build a formula column, and let's take a look. We come back in our data table, and we can see a right justified value. So we know that JMP is representing this as a numeric. You can also look over here in the columns section to the left and see that that's got the little blue triangle. So it's continuous data. That's what we wanted. And it's done our formatting for us. And in fact, if we right click and look at the formula, you can see that JMP has written this script for us. And so if you're interested in dates and times and some of the functions associated with them, you can certainly go through this script and see what's going on. But the beauty of it is, if you don't care, you don't have to care. This was all written automatically by you know, interpreting those selections that you made in the menus. All right, so that's our first type of problem where we have character delimiting, and that'll work on, you know, any of these. You could do that way. Now what happens in the other case where, you know, take a look at this military time format, and something interesting going on here. If you look at what I've highlighted, there are 6 numbers, and then there's a Z, that's Zulu time, that's Greenwich Mean Time. I need to break these up based on position. There are no delimiters, and in fact, that 11 that starts this off, that's actually the day. That is 11 April, and then 14:30, you know, that's 2:30 p.m. So I have to tell JMP how many characters we're working with here so that it can break things up. So let's see an example of that. I will, however, delete this date column that we built just to get us back to start. I'm just going to toggle back and forth between these to refresh the display. And here's that first row of data now. And when I choose fixed delimiting, watch what happens. I get this little red tick mark. And I'm going to put tick marks in front and behind everything that I want to delimit. So this 11, I have to tick mark in front and behind, and the 14 and the 30, the beginning and end of the April, the beginning and end of the 98. And that's what I care about. And I have to look at this year. Okay, right now it's 98, so it's a 2-digit year, and I've got a couple of choices. I could just assume that this is the 2000s, but that's not what we want here, right? We don't want this date to be 2098. So we'll do a custom look back. And the way I like to think about a custom look back is you think about how far in the future you'd actually like to look, and then subtract that from 100. So let's say in this data set, I'm never going to get a date that's more than 10 years into the future. Well, then I'd like to look back 90 years. So I can just come here, look back 90 years. And that's going to make sure that things like 98 shows up as 1998, 38 shows up as 1938, but something like 25 would show up as 2025. So we can go ahead and apply the delimiting, and that's going to refresh these drop-down menus. So now remember, I said that this 11 was actually the day, and the 14 is our hours, 30 is our minutes. April's our month, but it's a 3-letter month. We don't have complete name months here, so we got to make that selection. 98 is our year. And this is Zulu time, so I'm not going to apply any offset, but I will put things in my favorite format. Go ahead and build that column, and let's take a look. Okay, and as we see, let's take a look at the years. This last line had a 38 year. Well, that's getting written as 1938. It's 11 April. Now 12:30 is going to be 12:30 p.m. and so we've got that. Okay, here we've had 14:30, so that's written as 2:30 p.m. So it's all looking good. Again, if you want to take a look at that formula and see what's going on, there it is. And so between, or among, I guess I should say, these options, this should get you pretty far, whether you're just able to change the data type like we did in the first example, whether you have to do a really quick formula column and use the in format command to turn things into numbers, or whether you have a really special case and you need to define explicitly some delimiting scheme, whether that's fixed or whether it's character delimited. You've got options here, and this should, once you try these, this will fix, put it this way, if it doesn't fix your date and time issues, you got to let me know, and I'll see what I can do about updating the add-in, because this covers most of the options I can think of out there. So looks like we got a couple minutes left. That's all I've got, Julian. I don't know if there were any questions or anything like that, or if you just want to take it back.
Thanks, Brady. Yeah, I'll grab this back. And actually, one question I think some people may have is how they can ask you questions or put in, I don't know, request for the doctor to cover something.
Oh, yeah, I'm glad you mentioned that because I forgot to. And, for this segment, as Julian said in the beginning, this is about you guys and about the problems you're having. And so I can try to think about the problems you're having, but, it's better if you let us know. So I don't know if you've set up a special space or we could do that on the community somewhere, Julian? Or...
That's right. Yeah. So your episode page actually will be a great place. People can comment on this episode, but we'll probably get you a special place too, because I imagine a lot of people would like to ask you some specific questions.
Perfect.
So yeah, we'll report that. Yeah, we'll report that back. And this is a recurring segment, so every Friday we get to hear from the doctor. So yeah, definitely please submit your questions. Thank you so much, Brady.
Thanks, everyone. Thanks, Julian.
Yeah, take care. Great. So our next segment is going to be actually community focused. So actually Ryan Gilmore, the community manager, is going to take us a little bit through why the JMP user community is such a great place for you to submit your questions. And if you're not a member yet, why you really should consider joining. So Ryan, please take it away.
Ryan Gilmore, JMP User Community Manager. I started my career in JMP technical support. The policy then, as it is now, was that a JMP user could expect an initial response to a question within 24 hours. The user could then expect additional communications every 3 business days. With that in mind, let me show you a couple of graphs that I've published to JMP Public that show initial response time is one of the benefits of being a member of the JMP user community. The first graph shows the initial response to a question posted in the community. Notice that there's a 91% chance that you'll get a response to your question within 24 hours. The next graph shows there's an 85% chance that you'll get an answer to your question within 48 hours. What makes this so impressive? These responses are coming from other JMP users. Today, I want to give you 3 tips that will help ensure you get the information you need quickly when asking the JMP user community for help. Tip 1. Use the Insert JSL Script button to add your code to the post. This will properly format the code, making it easier for others to read. It also prevents the JSL code from being translated to another language, allowing you to copy it directly from the browser into JMP Script Editor and quickly make use of the solution provided. Tip 2. Use content mentions. Just as you can @mention an individual, you can @mention content as well. This makes the content of your post easier to read, since you don't have long, complicated-looking URLs. Also, you don't need to search for an article in a separate browser window, copy the URL, then paste into the editor. To find content, you can perform the same search that you would within the community. Finally, tip 3. Select the label. We use JMP's Text Explorer to analyze the content of posts within the community and discovered that most of the content could be categorized into one of the following: analytics, data table, DOE, graphics, and scripting. By labeling the post, you make it easier for the domain experts to find your question and other community members to locate the answers to their questions. To review, when starting a discussion in the JMP user community to ensure you get the information you need quickly, use the Insert JSL Script button to add JSL code. Use content mentions to reference other content within the community. Select one or more labels to categorize your question. If you have any comments or questions about these tips or other community-related issues, send me a private message in the community. My username is Ryan_Gilmore. Thank you, and remember, the community is always there. No matter where you are in the world or what time you log on, community.jmp.com.
Fantastic. Thank you so much, Ryan. And again, if you are not a member of the community, it really is a wonderful place to join. I remember when I first started using JMP, the community wasn't around, and I really felt like I didn't have the place to ask my questions. So I'm actually a little envious of all the new users these days who get to go to some place as wonderful and vibrant as the community, ask their questions, and get a response so quickly. So community.jmp.com, absolutely worth visiting after our show. So our next speakers, our next program is going to be about a different use of JMP, something that you may not have thought JMP can really do. So Jordan Hiller is actually going to be talking with really JMP superstar and emeritus developer Craig Hales to talk about how we can use JMP to actually create abstract art. And so I'm really interested in this show. So let's see that JMP can do that.
Hi, I'm Jordan Hiller. Welcome to the first installment of JMP Can Do That. In this segment, we'll look at unusual, interesting, and sometimes just plain silly projects made using JMP software. Today, we're talking with Craig Hales about his intricate and eye-catching video animations. Craig retired from JMP last year after a 40-year career as a software developer. He was a prolific contributor to many aspects of JMP software, and he is also quite active in the JMP user community. If you ever post a difficult question about JSL to the user community site, there's a pretty good chance you'll get a reply from Craig with a helpful, concise, and very elegant solution. He also maintains a blog, very active, called Uncharted, where he writes about JSL scripting, data processing, and his animation projects. Welcome to JMP On Air, Craig, and thanks for joining us.
Hey, Jordan, thank you.
While we talk, Craig, I'm going to start off by showing one of your videos called Curvy Vine. Let me bring it up right here. Share my screen.
Oh,
Okay.
excellent. That's actually looking pretty good there.
Oh, good. Yeah, I don't know how well this is going to work for all the viewers, so in a little while, I'll switch to a slideshow of still images, but I just wanted people to get an idea for how intricate and beautiful these are. If you do find them interesting, please visit Craig's blog and YouTube channel after the show. We'll provide some links. So Craig, please tell me about your career at SAS and JMP.
Okay. Yeah, I was in the JMP group probably longer than anywhere else I was at SAS. I started at SAS pretty much right after I got out of school, and was in the SAS graph group for a long time, and moved into a video games group briefly, and eventually landed in JMP, and it's been great. Go ahead.
Yeah. Wait. Hold on. Video games division at SAS? I don't think a lot of people know about that.
We did have a video games group for a while, and that's where I really got my C++ coding skills, working on some video games. We shipped a few and had a few left over that never got shipped at the end, and it was a good time.
Sounds amazing. And so then you came to JMP. What time was that, and what version of JMP were you on when you came on to the JMP division?
So I started in the JMP group around 2000, 2001. They had just shipped the JMP 4, and I started working on JMP 5 and doing some of the 3D OpenGL support for the surface plot.
Here, let's get this going. Okay, yeah. And when you were at JMP, what project that you worked on there in your long career are you probably most proud of?
That would be the pattern matching software that I built into JMP. When I was still in school, I was using the Snowball language that came out of Bell Labs. And I wanted to bring some of that magical pattern matching stuff from Snowball into JSL. There's a add-in out there on the web, on the JMP community site for the Colossal Cave. That's a really great example of why you might want to do some pattern matching. That Colossal Cave adventure that nobody's ever heard of if you weren't computing 40 years ago. It was a text mode program that was written in Fortran, and I wanted to write some JSL that could look at the Fortran code and rerun it for me. And if you go out there and look at it, you can find both the Fortran code and the JSL parser for it.
So you wrote a Fortran emulator in JSL?
It was for that one specific program. It's not a general purpose Fortran emulator, but my goal was in fact to not have to modify the original Fortran source code. And I succeeded at that, but I may have written almost as much JSL as there was Fortran.
Sounds crazy. So that was your favorite project. What project did you spend the most time on at JMP?
I spent a lot of time early on building the OpenGL support that went on for several releases as I brought it up to speed, and eventually wound up handing it off to some other folks to work on. One of the really cool things that I put into the OpenGL support is the arcball support that lets you rotate on the rotate an object on the screen in a very natural way. That was a a Ken Shoemake piece of code from a long time ago that uses quaternions under the covers. And I learned just enough about quaternions to integrate that into JMP.
Interesting. And users today can still see that work in the Scatterplot 3D platform, as well as the Surface Plot, anywhere there's 3D stuff in JMP. Very cool.
Absolutely.
Yeah. So what was it like working at SAS? Was it a stimulating environment?
Oh yeah, we had lots of opportunities to do all kinds of things. One of the first things I wound up doing was building graphics device drivers to support hardware from HP and Tektronix and some other companies that were early on in that graphics process. And we got to invent the way that we were going to support those devices. It was really amazing.
Okay. So let's move on to your animations, and we're looking at the stills now, and I just have them on a loop so that they go while we talk. How did you get interested in computer animation?
So Space Wars and games like that were kind of popular when I was in school. And at some point, I think shortly after I got out of school, the Battle Zone game showed up with the vector graphics, just green lines on a black screen. It wasn't the raster graphics that we're used to now, but I was just amazed by that Battle Zone game. And it didn't do any hidden surface removal or anything. You could see through everything, but the outlines of everything was there. And eventually, when I had finished doing a lot of that OpenGL work, I got to build that into JMP in the form of the rat maze, which is one of the sample programs that if you go look in the samples, and you'll find some 3D samples under a hidden directory, or it's not hidden, but it's a directory under the samples directory. And one of those samples is a rat maze. And if you read the instructions, it'll work for you. It's the mouse controller isn't quite as much fun as the two joysticks on the Battlezone game, but it works.
I'd encourage all the viewers to go and check out that rat maze game. It is a lot of fun. It looks a lot like an early first-person shooter without the shooting, going through the maze there. Really fun. Yeah. So a lot of these videos seem to be inspired by mathematical or computer science concepts, cellular automata or fractals. Can you tell us a little bit about your inspiration and how these videos, the ideas come to you?
Sure, they come from all over the place. And some of them are rehashes of the same thing. If you look at the very first one I ever made and one of the most recent ones I've ever made, you'll recognize some similarities between the way I'm using the surface plot to generate images. Yeah, that one, the wave there, and later there's another one, I think. I really enjoy writing algorithms that iterate and produce the next image from the current image and have things that grow and change over time. So yeah.
Yeah. And what about the technical setup? Tell us in broad terms, how do you get from writing JSL code to something that you put up to YouTube?
Okay. I'm running JMP 15 in a Windows machine, which lives in a virtual box, which lives in a Linux machine. So it's all kind of deeply nested in there. Sometimes I do a little bit of work in Python on the Linux host for the virtual machine and connect to that with a socket from JMP. But mostly I'm doing JSL scripting. Sometimes I connect to a Raspberry Pi using the run program command and PuTTY. Sometimes I get pictures off the Raspberry Pi camera and bring those back to JMP. It's pretty straightforward.
So when you're making a video, are these all individual images that are saved separately and then pasted together to make an animation, or how does that work?
Yes, the JMP can make those simple frames that build these animations in less than a second if they're really simple. And sometimes I'm building really complicated frames that might take minutes. Most of these videos use 30 frames a second, and rendering all those frames can take an hour, or it can take weeks in some cases. There's a couple out there, the relaxed wind and the frantic wind videos, that took a really long time. Power failures get to be a problem because that was about 300 hours of rendering for those, which takes you a couple of weeks to do that much, and getting the power not to fail for 2 weeks is good.
Oh my. Let's see, were there ever times when your development work at JMP inspired a video project, or vice versa? Did one of the projects you were working on for a video inspire you to add something back into JMP?
It's gone both directions. When I added the data table subscripting into JSL, that was a direct result of working on some pictures I made of stars one night when I went down to the beach. I had a really dark place at the beach, and I pointed my camera up at the sky and made about 1,500 images as the stars moved by across the sky. I had an idea for combining and enhancing those images that needed all the images to stay loaded. And I wound up loading the entire set of images into one data table. We had a machine that could actually do that with a lot of memory on it. And then I wanted to be able to look through the rows and find pixels that belong together and that sort of thing. My original design was going to use a transform matrix, but that didn't land in the final design, but it did wind up being the data table subscripting to be able to access all that data. And going in the other direction, John Saul asked me to build a KD tree function to support clustering. And we exposed that KD tree function into JSL, and it's been really useful for building things like the third branch video, which if you watch what it's doing down inside, you can see it actually, a branch will run along until it gets close to another branch, and then it stops. And the way it does that is by using that KD tree function to figure out if it's about to run over something that's already been drawn.
Yeah. Interesting. I have used that data table subscripting. I'm glad that came from your work, because that is so terribly useful. Is there anything specific about JMP or JSL in particular that makes it particularly suited for this kind of work that you do with the videos?
Yes, the ability to be able to load an image into a matrix and then work with the matrix. I mean, one of my biggest challenges there is remembering that matrices are indexed with y comma x, unlike the screen, which I want to index with x comma y. There's a mental rotation there, but it's not really a big challenge. When you see the picture coming out rotated 90 degrees, you just go look for that pair of subscripts somewhere. It's really cool to keep images in data tables. I haven't done too much of that with the videos so far, but I've used JSL lists and the associative arrays in a lot of my projects. And once those JSL lists got faster, a couple of releases back, they became really useful. And the KD table, the wind videos and so forth, use the KD table to locate wind particles and weather stations that need to be modified as it's generating that video.
Nice. So if you had to choose one of these, I know they're all your children and so you love all your videos, but if you had to choose a favorite, which one would it be?
It would be the Chance of Dragons. That's a flocking or a schooling simulation. I stumbled into a set of colors for the fish that I really like, and it modifies the colors as it runs. I'm going to call them fish. They might be birds. And there's a really long-running Kevin MacLeod audio track that it's a Creative Commons track that makes it really soothing to watch. I tried to do something similar to that earlier with the spray video, and I really failed because I'd missed one of the 3 rules of flocking. Turns out when you're trying to do a flocking simulation, you need alignment, cohesion, and separation. Well, I got the cohesion and the separation, which pulls everything close to each other and keeps them from getting on top of each other. but I'd miss the fact that if the fish don't align with each other, they don't ever go in the same direction. That work looks a lot better in the Chance of Dragons.
That chance of it's mesmerizing, chance of it, watching all those little bird dragons, whatever they are, swim around together. Everybody should check that one out. Okay,
yeah,
so
I called it that because every now and then a pattern shows up that, okay, maybe it looks a little like a dragon.
I can see it. Yeah. All right. So if that's one of your favorite, did any of them cause you a heartache that was frustrating or challenging particularly?
The do not eat video. That's a really cool FFT analysis of the Kevin MacLeod track that's playing under it. The little buttons pop up and down every 30th of a second, showing you it's each button represents a frequency bin, and it's sort of like the bar graph on your stereo, showing what frequencies are playing. And long after I uploaded it, I found a really tiny error in the JSL that I'd written that made one of the 49 buttons be an exact copy of its neighbor. If I don't tell you which one it is, you might not notice, but I see it every time I watch it. And I mean, there's another issue there with the way OpenGL renders and use. If I was using a painter's algorithm where I drew everything in the back first, it would be perfect, but I'm just letting the model rotate and it may draw things in front first so they don't get anti-aliased against the background correctly. But if you don't know what you're looking for, you might not see that either.
I haven't seen it, Craig. I think it's gorgeous.
Excellent.
So how about new stuff? Any new projects you're working on currently that you can tell us about?
I really don't like talking about my new projects until they're really ready. I'm trying to write an add-in right now that'll make it simpler to make these videos, but it's not ready for anybody to look at it yet.
Fair.
And I've got some other projects I'm hoping to get back to. So
yeah, and any other artistic endeavors that don't involve jump?
I've definitely done some things outside of jump. I've helped my daughter Jen do some time-lapse videos of her painting process. And one of the things I learned from that is if you name a video Underwater Escape, you'll drive a lot of traffic to it. I've got another video out there called All Eyes on You that you can find in my channel. That's a proof of concept of a video filter for a Raspberry Pi. We've used that at a couple of Halloween parties and works really well. Yeah, pretty much.
I liked All Eyes on You. Everybody should check that one out too. So last question, if anybody else is looking to get into this, wants to get started with animation, what advice do you have for people who are just getting their feet wet with this?
If you're just doing an animation like the ones I'm making, you probably want to keep it short, less than a minute. People don't have enough attention span to look at long animations. You want to make your pictures 1920 by 1080, or maybe twice that big if you're doing some really detailed stuff. You want to use 30 frames per second if you don't have any reason to pick a different speed. You want to keep your music legal. I like using the Kevin MacLeod Creative Commons music, and sometimes I write my own music. I write my own audio. I won't call it music. And you know, I use Blender. It got a really, really long learning curve as a program for assembling the videos. You might want to pick something else for you doing your video, for creating your AVI or MP4 file out of your frames. But video, Blender will work, and if you've got some time to spend.
Nice. Well, thanks, Craig. This was a lot of fun. Appreciate you sharing some of your work with us.
Well, thank you, Jordan. It's been fun, and hope everybody out there has safe time.
Thanks, Craig. If you'd like to see Craig's animation or learn more about the tools he uses, check the episode page. We'll send the link after the show. And we'll see you next time on Jump Can Do That. Julian, back to you.
Thanks so much, Jordan. And thanks so much, Craig, for joining us. I always love hearing what Craig is up to. And so I'm really pleased that you are joining us for today's show. All right, in our next segment, we're going to learn really quickly about a stat concept in our week's episode of Stat Snack, where we take bite-sized pieces of statistics knowledge and serve them up to you.
Hi everyone, I'm Olivia Lippincott, a jump systems engineer. Let's talk about what a one-way ANOVA is, or analysis of variance. So some of the questions that might be answered by analysis of variance are things like, are higher priority jobs being completed more quickly than medium and low priority jobs? Is braking strength the same between different processes? And some of the things these questions have in common are they all have one factor or one categorical variable mentioned within the question. And that one factor is where we get the name one way from. For instance, priority jobs in the are higher priority jobs being completed more quickly. And different processes in the question of is braking strength the same between different processes? And the key for doing an analysis of variance with this categorical factor is there needs to be 3 or more groups within that factor. So there's a high, medium, and low priority jobs, or there can be process 1, process 2, process 3, and process 4. The other thing these questions have in common is they all have one continuous variable that's being measured. And in ANOVA, we're looking at the differences of means of a continuous variable across at least 3 levels of a grouping variable within there. So continuous variables might be something like completed more quickly, which could be a time variable, or braking strength in the case of is it at the same between different processes. Let's take a closer look at braking strength, and is the braking strength the same across different processes? If we take a look at this data and graph it out, I've got braking strength on my y-axis as my continuous variable, and then processes on my x as my categorical variable. And then this example, I've got 3 processes that we're looking at and different measurements of strength between those 3 processes. Now, an ANOVA uses a test statistic called the F ratio. And we can think of this as a ratio between the difference between the means of the group divided by the sampling variation. Or another way to kind of think about it is the signal to noise ratio. And with that ratio, we have what's called a p-value or probability value for that test. And that's measuring how extreme that F ratio is. So in our example of braking strength is the same across different processes, we're going to think about it as if the p-value, if it's greater than 0.05 or a larger number, then we're going to say the average braking strength is the same between the 3 processes. If the p-value in our test turns out very small or less than 0.05, then we know at least one process differs in average braking strength, though through this test we won't be able to tell which one is different. So we ran the analysis, and on the left-hand side we've got a graph of the strength by process where we connected the means between those 3 processes, and already those look pretty different. When we ran the one-way ANOVA, we get the results on the right-hand side, and we can see that F ratio is pretty large at 24.3163, and the probability value is pretty small at 0.002. So that low probability value, or p-value, tells us at least one of those processes differs in average braking strength. And that's for one-way ANOVA.
Fantastic. Thank you so much, Olivia. Now, if anyone has additional little bits of stats knowledge they would like to hear about, definitely post it to our Stat Snack episode page, and we'd be happy to get some bite-sized pieces of stats knowledge out to you. So I'm excited about our next segment here, which is going to be showing us really a fundamental platform in JMP, which is the essentials of Graph Builder. And so I'm excited to have Laura Higgins on here to tell us about the essentials of Graph Builder. And Laura, do we have us with you?
We do.
Fantastic.
I've been watching you on the iPad next to me, so let me do it. Can you hear me okay?
Yeah, hear you just fine.
All right, I'm gonna just get right into it here. So, Julian, I found you very inspirational. I really enjoyed your segment on the supercomputer. And so it really got me thinking. So can you imagine if we put JMP on a supercomputer? You know what that would be? That would be cray cray. Right? That's kind of silly. So let's skip the introduction. All right, so the other way that Julian has inspired me is that he's done a lot about the quantified self, right? And so this really got me thinking, how have I been spending my time the last couple of weeks, right? And what I'd like to do, what have I been doing? Right, and I'm gonna try to quantify some of this. So watching Netflix, yes. Looking at kittens on the internet, yes. Learning about geography and drinking, yes. So let's look at some of this. So what did I do? So I downloaded my Netflix history. All right, and you can do this. Just go to your account, and you can see all kinds of fun things here that I've been watching. And I'm going to show you Graph Builder. Right? And so the first question is, what's in this data set? So, and maybe in another episode, I can show you how I got this data. I actually ended up using the new JSON importer. But you can see here, I have series title, episode. There's blank spaces here, and these are movies, right? So it's going to tell me a little bit. So I love Graph Builder for just trying to see what's in a data set. And I have a lot going on here. So I'm going to make this a little bigger. And I've clearly watched a lot of series. But what series did I really watch the most, right? Because I was like, wow, look at all these. I have no idea. So what I did is I'm going to use a bar graph because it's just going to do a count for me. And then I actually like to have it order it by ascending, right? And then, so now we can really start to see, boy, there's a lot of stuff that I apparently did not care for. So, but then there are some things that I've watched 80 to 100 episodes of, and it may not have been me. I have had other people watch Netflix on my account. So if you ask me about some of these shows, probably I might have watched them, I might not have. But let's see. So all I'm doing here is moving the axis around because I just really want to see more detail about what have I been watching, right? And so it looks like the things that I have watched the most episodes of. All right, so here, this is everything I've watched over 20 episodes of. So everything from American Dad and Black Mirror and the most 30 Rock, Archer, Battlestar Galactica, House of Cards, right? So definitely some very popular things. Some things people may not know about. Ghost in the Shell Standalone Complex is one of my favorite animes, and all kinds of things. So I have a date in here too, And so I certainly didn't watch all this in the last year. And so you can do this cool thing. So I'm gonna leave this up and actually get another graph builder, because I just want to show you real quick. So for date, right? So my date goes through, it has day, month, and year. And I started watching Netflix in 2009. You know, what's funny is if you look, you can see just even by the density of points here, and we'll get more into this. It's more dense here, right? And then it gets sparser as we go out, as there's other streaming services. I haven't just used Netflix, right? But so I don't need a graph every single day to look at my series. So what I'm gonna do is I'm gonna do this right click, and I can just do this right click formula column and make year, right? And it's year 2, because of course I've already done this, because I always do my homework, because I'm just that kind of person. What you can also do is you can just add that to the data table, right? So then I have a new variable called year, and I'm going to make that ordinal, and then I can take that and put it up here, right? And then now you can see, we can get a little bit better idea of when I would watch this, you know, and sometimes coloring helps. In this case, it doesn't, because each row is an individual object, right? But so you can definitely start to see patterns here. One of the other things I like to do for things like this is I'm going to turn on the grid, you know, and then that gives your eye a little bit more room to connect lines. So I haven't watched 30 Rock in years, right? And so I can see, what have I been watching more recently? Looks like Breaking Bad. I was a little late to the Breaking Bad. And there were some other things in this data set. So there's this thing, device type, and I didn't really understand what that was. I put it in here as a color, and it turns out Netflix has started tracking devices starting in about 2007, right? And so there's no device type. Everything's the same color up here to 2016. Okay, and then we can see that there's different devices. You know, and again, like I know what this is. Like this is my cell phone, because I've been watching Breaking Bad on the airplane, you know, and so we can also learn something about what Netflix is doing just by looking at my history, right? So that's all kind of fun. And so that's some stuff about series. I'm going to hit start over here. And so let's go back to this date, right? And then there's also duration here. And duration comes in as seconds, but I put it into hours, minutes, seconds. And so this is everything. And again, you can see back here in the data table, I have 3,000 items here over the last 10 years. And what on earth is 5 hours? Black Mirror Bandersnatch, right? So if you saw this, it's kind of a choose your own adventure story. And so there's several hours of content depending which way you watch it. And then there's some other ones here. The Irishman, you know, this is, everybody probably heard about this at Christmas time. It's kind of a long movie. Apocalypse Now, right? So there's some long movies, and again, if you just kind of look at the pattern here, I think this is pretty interesting. So if I'm going to turn this on. This is a density plot, right? And so again, if you look at the scale here, so it changes scale a bit. 0 hours, 1 hour, and 2 hours. And I always like to look at patterns and not just the data points, because you're really trying to do some summarization. And, you know, here's a whole lot of series that last, you know, about 30 minutes. And then here's all the series that last about 45 to 50 minutes, right? And then these are my movies up here, right? And again, so now it really starts to stand out when I look at the averages that I definitely watched more Netflix in the past than I watched today, you know, and certainly I had to get my Game of Thrones action on, so that took away some time from Netflix. So that's one way to look at this. If I could put the bars on here and check this out. And again, it's duration. So instead of mean, right, I could do sum. And this is every single day. And talk about bingeable. And there's a few days in here, like we're watch the whole series for 12 hours a day, but you know, most of my use, and again, this might be multiple screens running at the same time. But so is Netflix bingeable? Yeah, absolutely. Let's see. So there's some things we can do to make this graph a little more interesting. But then, so what I'm gonna do is I'm gonna start over, and duration. So I like looking at time data in a little bit different way. So again, what I've done is I did this right click here, and I pulled out different features from the date and time. And one of those is day of the week, right? And so again, I can use my bar here, but I actually like using a heat map. And, you know, what we can definitely tell is I watch more on the weekends, and then there's a lot of things that are an hour or less, which are probably, again, series, or I do like watching cartoons. You know, there's that 1 5-hour one. So this is across all 10 years of data, right? So I can take my year and put it up here as a group, right? And so notice, so this is year as continuous, and it does some nice job grouping it together. And that's going to show up different than if I take year and put it up here, right? And then we can also take month and put it over here, right? And so this is a nice little grid of what I've been doing, right? And one more graph that I actually really like was, you know, there's this really fun way to do bars, and instead of the side-to-side bar, I like this packed bar, right? And so this is going to show me more details, and you know, this is the favorite thing that I came up with. And then I can color, and again on this one I'm going to use my year as continuous to color, and I don't really like that, so I'm gonna change the color in the gradient and put this on here like this. Come on now. And you can add more information with the slider, and I can color. So this is, I think, the best representation of what I've been doing on Netflix, right? Where you can really see, you know, you get all the information in one graph of time, year, details. You can actually read some of the different things that I've been doing, and you get a sense of what I've done recently versus in the past. All right. So this is a little bit of what I've been doing. So the other things that I've been doing, I've been watching Netflix. I don't have time to go through all of these, so I have some geography things, but I'll show you real quick. So some kittens. So I look at kittens on the internet. It's fun, it's relaxing. And again, I can, maybe on a future show, I'll show you how I did this. So there is this file, internet open, and I just did a Google search for kittens, right? So I can get kittens into the data table. So I have two of my favorite things, kittens on the internet, kittens into JMP, all right? If I look at Graph Builder, I had to quantify my kittens, right? So I have my number of cats, and they show up as data points, but hey, I can actually take pictures and turn them into markers. And now I have my kittens, and zoom in a little bit here for you. So we have kittens in the data table, and then I can get even more kittens, and I can actually use them as a label. And then if I go back to my Graph Builder here, and I hover over the data point, and get a label to come up, right? There's my label. So kittens into Graph Builder in JMP, and I think I am out of time. So that's a little bit of what I've been doing. So Julian, thanks for the inspiration, and I'm going to turn it back over to you.
Fantastic. Thank you so much, Laura. I was looking at your top viewed shows, and I'm surprised at, maybe I'm not surprised at how many we have in common. So we should maybe share our viewing history and take a look at it together. Now, we'll actually post a link on your episode page where those of you at home who have Netflix can also get your viewing activity. It's just netflix.com/viewing activity, and you too can download your data and play around to see your patterns and trends and what you've been up to. So I encourage everyone else to do that as well. Our last segment is a Have You Tried, where we take a very short look at a really great feature in JMP. And this week, Ryan takes us through the Prediction Profiler.
The Prediction Profiler in JMP is a great way to interact with complicated statistical models. With the profiler, you can interactively generate predictions from your model as you change settings of individual factors. Visualize interactions, like how the effect of one factor for your response can change at different levels of another factor. Find optimal settings for your factors based on goals you have set for your response variables. And perform what-if analysis by simulating responses based on specified distributions for both your factors and responses. If you have previously saved a model as a formula column, you can access the Prediction Profiler directly from the Graph menu. Otherwise, access the Prediction Profiler from the red triangle in a model report. Using the tire tread sample data, I've used FitModel to generate a response surface model for the variable hardness based on several factors. The Prediction Profiler is showing a cross-section of the model. The prediction of hardness is on the left, with a confidence interval based on the current settings of silica, silane, and sulfur. The curves of each factor show the relationship between the response, hardness, and each factor at the current levels of the other two factors. For example, if we look at a plot with silica, you can see that the relationship between hardness and silica have curvature when silane and sulfur are at their middle values, and that lower values of silica appear to result in more hardness. As we change the value of silica by dragging the red trace lines, the prediction of the model on the left changes. With the Prediction Profiler, we can also see interactions among our other factors. For example, let's see how the relationship between hardness and silica changes at different levels of silane. I'll drag silane to the low and high levels. The Prediction Profiler helps us see the statistical interaction. At low levels of silane, higher levels of silica are associated with more hardness. But at high levels of silane, lower levels of silica are associated with more hardness. In complicated models with interactions, it can be very difficult to manually find settings of our factors that give us an optimal response, which in this case is to achieve a hardness of exactly 67.5. The prediction profiler can find the optimal settings for us. I'll select Prediction Profiler from the red triangle and select Optimization and Desirability, then Desirability Functions. Desirability functions are added to the profiler, which show how particular desirable levels of our factors are if we're trying to match a hardness target of 67.5. To let JMP find the optimal factor settings, I'll select the Prediction Profiler red triangle and select Optimization and Desirability, then Maximize Desirability. To achieve a hardness of 67.5, we can use the factor settings the Prediction Profiler has found for us. Finally, the Prediction Profiler has a rich set of tools to perform what-if analysis using Monte Carlo simulation. I'll select the Prediction Profiler red triangle and select Simulator to turn on the simulation tools. Here I can see distributions for each of my factors if their values cannot be completely fixed. And when I select Simulate, I can see the distribution of hardness we can expect. The Prediction Profiler in JMP is a powerful tool for understanding your models. To learn more, search Prediction Profiler in JMP Help.
Fantastic. Thank you so much, Ryan. And if you haven't tried the Prediction Profiler out, you definitely want to. It's actually one of my favorite features in JMP. And it really, when I first started using it, really helped me understand statistical models in a way I never had before. All right, so we're coming to the end of our show. Before we do a final wrap up, I just want to make one announcement, which is that the call for papers for our CARI Discovery Summit series is now open. So we'll put the link in our episode guide so you know this, but Discovery, if you've never been to it before, is really the best place of coming together of all the JMP super users and the people who have even just started using JMP, and they share the things they use JMP for, and it's just such a great environment to learn and to expand and deepen your understanding of JMP. Now, CARI Discovery Summit will be partially online as well, so even if you can't travel or don't think you will be able to, still submit your abstracts and we'll have an online version of the conference at the same time. So definitely check that out and consider submitting or just coming if you're a brand new JMP user. All right, so after this broadcast, I mentioned it at the start, community.jmp.com. You'll be redirected to for the episode page. Definitely leave your comments there for any of our shows or things that you want to see in this broadcast, because again, JMP On Air is about you, the JMP user, and we want to make it absolutely fantastic for you. So let us know how we can do that. Follow us at Twitter, Facebook, YouTube, Instagram, and LinkedIn, really all the places around the internet. Make sure to follow us because we have lots of things we love to share with you. Check out the program guide that you're going to get on Sunday night. That'll include all the programs for next week. So we have some great things coming up that we can't wait to share with you. So make sure you're subscribed at jmp.com/JOA. And if you need to share this with colleagues, definitely share our links on social or even share that short URL with them over a phone call or over a Zoom meeting like this. Get them involved too so that they can also benefit about learning these things with JMP. So we really appreciate you joining us. We hope you join us Monday, and we hope you join us every week and every day that we're on air so you too can learn more about JMP, statistics, science, and really have fun with us in an environment that's informative, but also all about learning. So thanks so much for joining us, everyone. I hope you have a great rest of your day. I hope you stay safe. I hope you stay healthy, and I hope you stay close, even if you're keeping your distance.